Section 6.6 is about variation, and that's the last section we're going to cover in this chapter. So why don't we discuss what variation is? Direct variation, there are multiple types of variation, but they're all related on how two variables connect. So let's talk about direct variation. We say that y varies directly as x if there exists a real number k such that y equals k times x, and we call k the constant of variation. So here are the steps for solving problems with direct variation. What we're going to want to do is we're going to want to write a variation equation. We'll then substitute our initial values and solve for k, and then we can rewrite the variation equation with the value of k. This isn't necessary for all projects for all problems for step 4, but step 4 is to substitute the remaining values and solve for your unknown. So it depends whether your answer is just to find the variation equation or to solve for the unknown. So why don't we work through a couple of examples? Our first example of direct variation is this. Eva Lechman is paid an hourly wage. 1 week, she worked $43 and was paid $795.50. How much does she earn per hour? Okay, so let's think about it. So y varies directly as x. Okay. My income varies directly with the number of hours I work. So you can't just set this up. You have to think about, okay, what varies directly? Where k is how much I make an hour. We're pretending this woman doesn't have to pay taxes. So I'm going to write the variation equation, which is y equals kx, because I have direct variation. I can then substitute in my initial values. So now I have $795.50 equals k times x, which is the number of hours a week I work, which is 43. And I go ahead and divide both sides by 43, and I find that 18.5 equals k. Okay? I can rewrite my variation equation with the value of k as y equals 18.5 times k. X times x, oh my gosh, times x. Now, step 4 is substitute the remaining values. We don't need to do that, but it is asking us how much she earns an hour, which we can determine is what our k was. So our final answer is $18.50 an hour. So let's go through an example where we do have to use step 4. Hooke's law for an elastic spring states that the distance a spring stretches is directly proportional, so varies directly, to the force applied. So distance is directly proportional to force. If the force of 150 newtons stretches a spring 8 centimeters, how much will a force of 400 newtons stretch the spring? So I first know this is direct variation, so I have y equals kx, where my distance is my y and my force is x. Next, I want to substitute in those initial values. So I know that my spring stretches 8 centimeters when 150 newtons is applied. So I go ahead and I divide both sides by 150. And I get that 4/75, because I simplified, is my constant k. So then I can rewrite this as y equals 4/75 x. Now, what I want to know is how much will a force of 400 newtons stretch the spring? This is when we have to use step 4. Substitute in the given value and solve for our unknown, which is the stretch of the spring. So I have y equals 4/75 times 400, because that's my x value. That means y equals 16 centimeters. So our spring will stretch 16 centimeters. All right, now let's talk about direct variation as a power. So y varies directly as the nth power of x if there exists a real number k such that y equals k times x to the n. So let's take a look at our example. The distance a ball falls varies directly as the square of the time it falls. So our time is our x, but we're looking at the square. And the distance a ball falls is our y. So I'm going to go ahead and write my equation of y equals k, some constant, times x squared. Next, I've given some information. If a skydiver falls 64 feet in 2 seconds, how far will they fall in 8 seconds? So I'm going to have to use all 4 steps here. So for step 2, I have that 64 equals k times 2 squared. So 64 equals 4k, so 16 equals my k. I then can rewrite this as y equals 16 k squared, not k, x squared. What I then am going to do is I'm going to substitute in, I want to know how far will they fall in 8 seconds. So I'm going to take y equals 16. Did I do that right? 64 divided by 4. That's 16. It's 2 seconds. Okay, cool. So y equals 16 times 8 squared. That means y equals 16 times 64, which is y equals 1,024 feet. That seems like really far to fall in 8 seconds, but that works because it's when y varies directly as the nth power of x. There are 2 more types of variation that we need to discuss. One is inverse variation. Y varies inversely as x if there exists a real number k such that y equals k over x. So, in the manufacture of a certain medical syringe, the cost of producing the syringe varies inversely with the number produced. So our cost is y, and that varies inversely with the number produced. So I can write my equation as y equals k over x. Now, if 10,000 syringes cost $2 per syringe, I need to find the cost per syringe of producing 2,500 syringes. So I'm going to use all 4 steps, and I go ahead and label them, but if you know what to do, you don't have to. So I have 2, which is my cost, which is y, equals k over 10,000. That's going to give me that k equals 20,000 after I multiply both sides by 10,000. I can then rewrite my equation as y equals 20,000 divided by k. Now, what I want to know is what's going to be the cost of producing the syringes if I need 25,000 syringes. So I have y equals 20,000 over 25,000. So y equals 0.80 or 80 cents. The last type of variation we're going to talk about is joint variation. So we say y varies jointly as x and z if there exists a real number k such that y equals kxz. What's really interesting is you have seen joint variation before. Remember this formula for interest? Interest equals the principal times the rate times the time, right? That's our joint variation formula. So here for a given principal P, the interest earned varies jointly on our rate and our time. So if an investment earns $100 in interest at 5% for 2 years, how much interest will the same principal earn at 4.5% for 3 years? So I have, my interest was 100 at 0.05 for 2 years. So I get 100 equals 0.1p, so 1,000 equals our principal. I can rewrite my equation as I equals 1,000 RT. What I'm then going to do is I'm going to take, for problem 4, I substitute in our new rate for our new time. I want you to know no one's going to give you an interest rate on a $1,000 loan like that. Let's be honest. So we have 1,000 times 0.045 times 3. That's going to give me an interest rate, not an interest, but the amount of interest I will earn off this principal will be $135.